The broadcast is now starting. All attendees are in listen-only mode.
Hi, everyone. I'm Nancy Molenda, Vice President of Communications for the Aluminum Extruders Council. Welcome to our webinar, Aluminum Extrusions, Designing to the Limit of Your Imagination, and Tips for Designing a Successful Design Competition Entry. I'd like to tell you a little bit about us. AEC is an international trade association dedicated to providing information and education about aluminum extrusion and its process. David Asher is one of our speakers today. He is Process Optimization Manager for Bonnell Aluminum, headquartered in Union, Georgia. They are an extruder. And Todd Boyer is Director of Business Development for Mid-States Aluminum Corporation in Fond du Lac, Wisconsin, and they also are an extruder. Both of our speakers today are judges for the Aluminum Extrusion Design Competition and have been for several years. Their experience in judging the entries has helped us to hone the information and requirements for the design competition with the intent to focus the students' learning and better understand the extrusion process through design. The presentation today will briefly cover the basics of the aluminum extrusion process, the advantages of aluminum and aluminum extrusion, and then take a deep dive into the factors that students should take into consideration when designing with extrusions. This information will help provide you guidance in developing an aluminum extrusion design that may have the potential to be a winning entry. Before we begin, I have some announcements. All computer, audio, and telephone lines are muted, so if you have a question during the webinar, please select Q&A or chat from the toolbar. Type your question in the dialog box, and our presenter will answer your question at the end of the presentation. We are recording this presentation and will send you a link once it is posted. Also, the slides for today's webinar will be available after the webinar, and we will email them to all the attendees. And just before I hand this off to David to start our webinar, we'd like to know how many students and instructors are on our webinar today. So we have email addresses, but we're not sure whether you are a student or an instructor. So if you would please, in the question box, just respond whether you're a student or an instructor, or if you're neither, tell us who you are. Now, it brings me pleasure to turn over the presentation to our speakers for today's webinar. Here's David. Go ahead, David, take it away.
Good afternoon, everyone. This is David Asher with Bonnell Aluminum, and I'm here today with Todd Boyer, and representing the aluminum extrusion industry through our trade association, the Aluminum Extruders Council. Over the last several years, we have been attempting to reach out to various schools and universities to share more about our industry, our products, and again, how our products are used. And today's presentation in particular is going to focus more on what constitutes a good extrusion design as part of our annual design competition. But we're also going to be sharing with you information on aluminum, the aluminum extrusion process, as well as the details of the design. The first couple of slides that you're seeing here are really just showing some examples of applications for extrusions, and they go into a wide variety of industries, and you'll probably see them around you every day if and when you start looking for them. But with that, what I'd like to move on to is what our agenda actually is today. Again, I will spend a few minutes briefly going over the advantages of aluminum and the advantages of the aluminum extrusion process as a means of forming aluminum. Todd will be going specifically over a lot of the details of what constitutes a good design and what makes a design a potential winner in our annual design competition. And then we'll go through the actual details of what's involved in submitting a design to the design competition, what it is, and that sort of thing. and Nancy will conclude with telling you how to access several additional resources that can help you as you're preparing your design for the competition. As mentioned earlier, one of the things that we are trying to do a lot more of is actually visit schools and institutions and share even more about our industry. We try to structure our presentations to the specific class. We're willing and ready to present to engineering classes, design classes, any sort of class that is looking for more information on the extrusion process. We will structure a class that meets the requirements of the class. We'll have samples. We'll do our best to make it as interactive as possible so you can learn even more about our industry in addition to what you're learning about designing and using actual extrusion products. So as a starting point, just a few brief bullets on the advantages of using aluminum as a material, and then the advantages of using the aluminum extrusion process to form that material. Some of the most common recognized characteristics of aluminum are that it is lightweight and strong and has a high strength to weight ratio. It's also a very good conductor of heat and electricity. But as you'll see in the next couple of pictures here, showing applications, again, where its strength to weight ratio makes it a great material, such as space frames for automobiles and some of the structural components in a snowmobile. Interestingly, even within the snowmobile, one of the other wonderful characteristics of aluminum is it gets stronger as it gets colder. So it has wonderful characteristics, especially in cold weather, like Todd is experiencing in Wisconsin today. One of the other real benefits of aluminum is its recyclability. And I'm sure most all of you are aware that aluminum is highly recyclable, but you may not be aware of, again, some of the money-saving characteristics of recycling aluminum. To remelt and reuse aluminum requires only 8% of the energy that's required to produce virgin aluminum. That's one of the reasons aluminum has been widely recycled for years and years and will continue to be so. Within the extrusion industry itself, typically more than 50% of the aluminum that is used is recycled in some form or fashion, although much of it is the turnaround scrap that's generated within the facility, but much of it is also purchased from outside sources as scrap aluminum. So a little bit more about the actual process. Again, it is not a mystery process. Everyone has in some way or form been involved with the extrusion process. It really is just taking a malleable product in one shape and forcing it through a die into another shape. Play-Doh Fun Factory, if you actually look at the box, if you've ever seen one, it actually says on the box that it's an extruder toy. Another typical example of the process is a tube of toothpaste, again, where you're taking something in one form, in a somewhat malleable state, and forcing it through an opening into another shape. And that's exactly what we do in the aluminum extrusion process. We're just using aluminum instead of some of these softer materials. And again, the aluminum is still in a solid state. It is not molten when it's extruded. The picture that you're seeing now is kind of a very high-level overview of an actual extrusion process. You can see graphically at the top the sequence from start to finish, and the actual picture is 3 strands of aluminum that have been extruded and are running down a runout table. The extrusion process typically produces lengths that are around 150 feet long, and then they're cut back to sizes that are usable by the purchaser of the product. Real quickly before I turn it over to Todd, the true advantage of using the aluminum extrusion process is, aluminum, again, is highly formable, and we can incorporate many design features into the part that are difficult to do in other building materials. As you can see in the illustration on the left, we have incorporated potential hinge joints, screw slots for joining two pieces together, T-slot bolts, weather stripping grooves, heat sink fins. All of these different sorts of things can be incorporated into the base product and don't have to be added on in any sort of secondary operations. And likewise, with all the various features you can incorporate into the extrusion, you can have something that is easy to put together and take apart, as in the example of the scaffolding that you see on the right around the Statue of Liberty when that was undergoing a significant facelift a few years back. And with that, I'm going to turn the presentation over to Todd, who will be going into a lot more of the details of, again, what constitutes a good designed extrusion. Thank you.
Hi guys, thank you David for that great kind of overview of what's going on with the industry as a whole. In front of this slide is, it talks about tooling. That's a consideration, and the low cost operation of tooling. Maybe for $500 to $5,000 you can buy a die and have actual part in your hands and being able to go into production with something that you're wanting to do some machining or anodizing or painting with. And so when we look at that, we're thinking about, from a student or from an instructor professor's view, someone has an idea that they want to put into the design competition for consideration. And over the years, we've had just a really wide breadth of entries. And one of the things that we always think about is there's an idea for a product, but can it be made? Can it be extruded? Is it cost effective? And is there really a market for that product? And I think that's maybe some of the considerations. These are some of the limitations to the process that sometimes the entries we see they're physically too large or too heavy and not capable of even being an aluminum extrusion. So the other thing to think about is, what is the alloy? What's the strength requirements of the end-use product? And so this chart shows you that a very common set of alloys that are very good general purpose, 6063, 6005, 6060, those are really good application alloys for the bulk of products where you have structural requirements, body and white applications, structural bridge type applications. The 6082, 6061 is clearly an option. Then, can the profile that you're thinking about on your project be extrudable? I think that's really key. And so we're looking for balanced walls. They don't have to be the same thickness, but something that's reasonable. And here is a slide that just gives you some really good ideas. You're going to get a link of this, a link to this presentation, and I would encourage you to go back through and look at some of the design ideas. These are, hey, don't do this, it's this. Smoothing the transitions and trying to also reduce the cost of the part that you're considering. Many times we see customers thinking that they need to drill and tap the holes. And here is a great opportunity for self-tapping screws to be used, and where you can eliminate the entire machining process, hence the cost as well as the time to market to get that tooled up. So considerations for, so you got this extrusion, you got the right alloy, you find that it's extrudable, but what can I do with it? And that's, I think, the value of the aluminum extrusion is that you can do a lot with an aluminum extrusion. It's the shape, but then you can cut it, you can machine it, punch it, drill it, you can assemble it, you can paint it, anodize it, and your creativity can really, take a run with this. As an example of just some of the capabilities, here's an example of an LED light bar for an off-the-road vehicle. This one is a fairly tame extrusion, meaning it's extrudable. But the hard thing is the bending, and it's can you form that, and we call it the wrong way or the hard way, but that's what the application. So a great application for bending concepts. So I would encourage you to think it just doesn't have to be a straight part. It can be formed in many different planes, and there's great processes to do that. Also joining, there has just been a lot of innovation in the joining area. The adhesive bonding, the cold stir welding applications, the typical mechanical joining where you're joining it mechanically with fasteners. But I would encourage you to think not about just an extrusion, but how can you join other things to it or extrusions one to the other and making your end product. Another consideration would be, okay, you got the extrusion, you got the idea, it's extrudable, you got some cutting and some machining, you got some tapping in there, you maybe bent the parts. Now what do you do with the finish? Is it just going to be mill finish, or would you like it to be cosmetic, or do you need some special end finish that would meet your end use application? Maybe it's not cosmetic at all, but you need an anodized finish to protect it from corrosion. So here are some things to consider specific to the finishing of your aluminum extrusion design entry. Anodizing is a great solution for you. It's eco-friendly. It is not a plating. It's not something that's going to chip off. It's an integral part of the actual aluminum surface. And so you can get multiple colors. You can get it, as I call, sizzly colors, or just the standard clear satin anodize for you to use with your parts. Some examples in the building and construction industry of aluminum extrusions: office wall panel systems, atriums, bridge structures, and the like that you see here. Also, solar energy. Huge consumer of aluminum, brackets and structural support for that. And so if you're thinking of a solar project, there's a lot of information out there on solar extrusion applications that you can tap into as a resource and be creative and innovative in your design entry. The transportation industry, we talked earlier about the Corvette and the subframe of this, the body in white applications, but also the strength of aluminum versus the steel, copper, high-strength steels, etc. It is a great opportunity for taking weight out, bringing structural integrity to the vehicle, toughness, robustness, and here are some applications where it's being used. Another example, sunroof applications. If you're driving a vehicle, many of the vehicles are going to SUV, crossover applications, and many of those have large panoramic sunroofs, and in each one of those there are aluminum extrusions that are highly fabricated, formed, and anodized. Great opportunities to check it out when you look at your car or your father's car or your mother's car. There's a great applications there for you to get some ideas on. Also in the medical area, when you go, if you ever have an MRI, you're laying on that transfer table and you're going in and out. The table that you're riding on is typically supported by aluminum extrusions, as is much of the actual cylindrical portion of the MRI itself. So I would, as David indicated, extrusions are used in many different applications, and I would encourage you to just be creative and think outside the box, but then come back to the reality. Is it something that can be made what's the alloy, is it extrudable, and is it marketable? LED lighting is a huge consumer of aluminum extrusions. You can use these for troffers, exterior lights, parking garage lights. And in this application, you can see the original heatsink on the far left lower section had a large mass of aluminum. But on the new design, there is 4 voids in the middle of that. It allows this to reduce the mass, increase the thermal dissipation, heat dissipation, and also the cost, and make the extrusion much more extrudable from extrudability perspective. So, real quickly, we gave you some ideas on things to consider. Again, what's the product that you'd like to do? Is it cost effective? Can it be, is there a market for it? Is it extrudable? Have you considered some of the cost of design considerations? What type of fabrication or bending or welding or forming is required? And then finish. Could it be just a mill finish, a painted product? Could it be an anodized product? We're trying to give you some ideas, and we really appreciate the entries and the increase in creativity and innovation that we've seen over the years. And so with that, I'm going to turn it over about some ways that can be worked together. You'll get more information on the design competition and how to find also support resources as well.
All right, thank you, Todd. I'm going to spend a few more minutes going over some of the things that we as an industry would like to do, to support schools and students, and then some more details specifically on the design competition. So again, what can we do for you, the school? We can provide you with some learning materials and learning opportunities. We can come into the classroom and do presentations, again, structured to the specifics of the class itself. We can work with you on sponsoring like design projects if that happens to be a requirement of a senior class or something to that effect. Internship programs. We're always looking for again permanent employment opportunities for some of the students, in particular in engineering. But we are ready to come in and support you and provide instruction on a process that it typically is not widely known and understood in the academic environment. So again, we can also do plant tours if you happen to be near some of our facilities. But again, the primary purpose of our presentation today is to discuss some of the details of our annual Aluminum Extrusion Design Competition. So I'm going to spend just a few minutes going through the details of the timelines and how to get the materials to submit your entry if you're interested in participating in the competition. So again, the deadline this year is April 1st. So we'll go through where to find the information. Nancy will give you more details on that, on where to get the application and how to submit your entries. But just so you know what is involved in terms of the opportunities within the competition, and I'm fortunate to be a part of Bonnell Aluminum that is the financial backer of the competition this year. But we'll be giving away 3 prizes in the general category of first place, second place, and third place. That's from $3,000 to $1,000. And then we have what's called a sustainable design challenge, which is looking at things that in particular can be helpful to humanity. And that's a $2,500 award that is in addition to all of the others. So before we, I turn it back over to Nancy, I want to reiterate a few of the things that Todd covered off on what will constitute many of the characteristics that we're looking for in the judging. And as I think has already been mentioned, both Todd and I have been judges of the competition for several years, and we will be again this year, so we know what we're looking for. Be creative. Be creative in your use of extrusions and or a product that uses extrusions. Try to come up with something that's practical, useful, and scalable, and would have a potential market value. Make it producible. That's one of the things that Todd emphasized. Or what are the characteristics of an extrusion that make it producible? And I'm going to reemphasize a couple of those just to reiterate them over and over again. The profile needs to fit within a 10-inch circle size, if at all possible. It could be a little bit bigger, but it's preferable if it will fit within a 10-inch circle size. So draw a circle with a 10-inch diameter, and if your profile won't fit within it, redesign it. Do your best to keep the area of the profile. If you do a two-dimensional CAD drawing, do your best to keep the area under about 2.5 square inches, which will give you a weight of about 3 pounds a foot, which is another one of the limiting factors for many presses. One of my personal requirements of a winning entry is that the write-up associated with it is very professional. So if you're not particularly a great writer, have a friend who is, proofread your submission. In the last few years, we've also seen some 3D printed samples submitted that show what the extrusion would actually look like in addition to CAD drawings. It's a wonderful addition to your entry, and if you have access to those capabilities, again, I would strongly encourage you to try to do that. Again, more information on the details for the application forms and that sort of thing can be found at etfdesign.org as shown on this slide. The deadline, again, for entries is April 1st. And again, more information, and Nancy will be going through some of the things that are on the AEC's website, but more information is available on the AEC website. And so with that, I am going to turn the presentation back over to Nancy.
Okay, thank you, David and Todd, so much for a great presentation. So just to reiterate what David just said, you can find more information about the design competition at etfdesign.org. That's where you'll find the call for entries, you'll find the application, and you'll find some more information about some of the things that David and Todd talked about today. Again, the entry deadline is April 1st, 2019. If you want to get it in earlier, please do. It's funny, we always talk about, well, when are those entries coming? And as usual, and very predictable, students wait until the last minute to do everything. So we get our entries all, like a day or two before the entry deadline. So if you want to be proactive, go for it. We will hold on to your entry until the April 1st deadline, and that would be great. So if you're interested in instructors, if you're interested in continuing discussion on how AEC and the aluminum extrusion industry can help you in your classroom, you can contact me. That's my email address there, nmelinda@tso.net. Or you can contact our AEC Academic Engagement Coordinator. His name is Duncan Crowdis, and there's his email there, dacrowdis@gmail.com. And for some additional resources, the AEC website at aec.org is a wealth of information about aluminum extrusions. You have so much information at your fingertips there. We've got design resources, tips, extrusion application examples. We've got sustainability information. We've got just a number of different things, alloys, tolerances. If you're looking to find an answer about something that you're trying to work out with your design, look on the website. If you don't find it on the website, I encourage you to contact either myself or Duncan or even David or Todd. I don't know if we have their email addresses here, but definitely contact me. And if I don't have the answer, I will hand it off to one of those gentlemen to help you with your design. So we want to see you guys succeed. Other resources on our website. The Buyer's Guide is basically a way for professionals to find an extruder. But that also might be a good resource for you to see what kind of extruders are out there and how big of a circle size press they have. That would help you in your entry as well to see how many extruders do have the capabilities of producing your quote-unquote extrusion design. But I think the biggest resource for you would be to look at the Aluminum Extrusion Design Manual, or actually it's the Extrusion Manual. And you can find that at aecmanual.org, and that is just chock full of information about aluminum extrusions. And it also has a lot of the design tips that Todd went over. It has information about alloys, more in depth. It has information about dies and how dies are made, and there's just a wealth of information. So I would encourage you to download that manual. So with that, we have a little bit of time for some questions. So if you have a question, again, I would tell you to please type in your question in the dialog box, and I will read them off to our speakers. So let me see if we have any questions. It looks like, so we have no questions? So, okay, well, it looks like nobody has any real questions right now. So if you do have any questions, please let us know and email us. I thank you again for being with us today. And again, if you have any questions, contact us. We'll send out the presentation to you at the end of this presentation, and we look forward to seeing all of your really exciting aluminum extrusion designs. Thanks for being with us today, and that concludes our webinar.